Now let's talk about the macros, which let us shorten codes which uses some repetitive code pattern. Repetitive code pattern. So first of all, this is a pattern matching and replacement facilities. And this provides a mechanism to name frequently used code sequence. So we are defining a frequently used code sequence and naming them. Okay. Let's take an example. So let's say I'm defining and data label which could int underscore str, which like ASCII Z, we know what that is, and defining as a %d. And then we are doing something like this series of code LA move JL. So these three lines, okay, without going further detail onto what this LA is, what is move is, JL is, we'll explain it later part of the lecture, not today's lecture, but in a different lecture. But this three piece of code enables printing of an integer stored in a register, or let's call it a variable for time being, in a variable called $T0. Later we'll see this $T0, $A1, these are all registers. We'll see it later down the line in the next successive lectures. But for time being, let's say all these dollar things are a variable, okay, just for our understanding. So that's not important right now. The important thing right now is that this three set of code is enabling printing of an integer stored in a variable $T0. Okay, so this three piece of code. Now, that's what, I just explained, code to print values in the $T0. Now, how do I print numbers in a register? Or you can say it's a variable. Let's say I have like 8 variables, like T0, T1, T2, T3 till T7. I have 8 variables. I want to print numbers stored in those 8 variables. We call it a register in terms of assembly. One way is to definitely repeat the code for printing, right? This one like T0, and then you move like this part we are repeating move T2, T3, and so on and so forth till T7, right? So you can repeat the code for printing all of them. First of all, this A0 value remains same for all the prints, so that's fine. So we do not need to repeat it, but at least these two lines we need to repeat them to move, like to deal with different variables from T0 to T7. Now, other more elegant way is to do this. Define a macro like this. Okay, so we define a int string, okay, and then under that we define a macro. By the way, just to give you a quick introduction to .data and .text is what, like after .data, anything we write, it placed in the data segment. Now we saw that in the object code, right? And anything after .text, it will be given into the text segment. And to note, the macro, whatever we are defining here, can be defined under .text or can be defined outside anywhere. It doesn't matter. Okay, we don't need to necessarily define it under .text. It doesn't have any effect, that .macro, this guy, on the text or object code generated. Okay, we'll see why. So point is that this macro you can define anywhere in the code. Okay, I prefer usually to define it outside your .text and .data, but in this example I have given you this example just to show that we can also define macro under .text, after .text. No harm is done. But my preference is to make all the macro definition very upfront, very beginning of the program, even before the .data. Okay. But anyway, let's come back to our original discussion. So we define a macro like this. Dot macro is my directive. Then I give the name of that macro. Or in a turn, you can say this is a name of this three piece of code. LA, move, JL. These three pieces of code together, we call it a print underscore int. And then we define some argument list to that macro. Now this is the point where everyone mix it up with something like a function call at the higher level. This is not a function call. I'm repeatedly saying it to you guys that this is not a function call. You're not defining a function here. Don't ever mix it up with a function call. Okay, conceptually it's completely different thing. Let's try to understand that concept. So this macro name followed by, it can be followed by list of arguments. Okay, by comma. It will be like argument 1, comma, argument 2, argument 3. And by the way, this is just a name. Like it must be started with a dollar, by the way. Then after that, you can have any name. Okay, any name, any ABC, XYZ, anything. Just happen to be in this example, I name it as a dollar arg. But that doesn't mean you need to stick to that name. Okay, so this can be any name starting with a dollar. And it can be a multiple argument as well, not only the single argument. But anyway, then we are doing this, writing the code that we have seen earlier for the other way of repetitive code in my implementation. So I'm writing this tree line, but instead of writing the specific move statement with a $t0, I am replacing that with a $arg. I am saying that whatever I pass as an argument to this macro, use that one in this for the macro references. And once I'm done with the macro body writing, it's ended with a .end underscore macro directive. So this is my defining a macro statement. Once it is done, use it. So I can use it now as a print in $t0, print in $t1, print in $t2, t3, t4, etc., t5, t6. Okay. So instead of repeating these two lines over and over and over again, what I did, I defined a macro for this repetitive code and using that instead. So what happens underlying is that when assembler runs this, first thing before even do the like pass one, like where the symbol table is generated, it does another step. Okay, before the pass one, it does a pre-processing step where it expands on the macros. So what it means by that? So let's say this is your original source code you are assembling. So assembler does before the pass one, it does a pre-processing step where it omits macro definition. It just picks up this macro definition, store it in the storage, like intermediate storage in the memory. It knows what it defines, and then when you are referencing to that macro with certain argument in it, so it basically checks the footprint of the macro, and if it match, again, like this is the point where everyone mixes up it with the concept of function call. It is not a function call. Okay, it is just a blind expansion of your macro definition into a code. Okay, so what it does, it looks at, okay, print underscore int, is it in my macro definition or not? Is it defined or not? Yes, it's defined. It is basically these three statements. So it will blindly go and generate these three statement with replacing this $arg with this $t0. So in this case, $arg is $t0. So this guy will be $t0. So that's expanded. Next one, $arg is expanded with $t1. So we have $t1 in that expanded code, and so on and so forth till this guy. So with the macro referenced in the source code, after pre-processing step, it generates an intermediate assembly code with expanding all the macros into its defined sequence of codes. Okay, your macro definition is gone. This is consumed. This guy is not. This macro definition does not involve in your object code generation in any way. So it is just for the assembler reference that whenever I reference to a macro called print underscore int in this example, how I am going to expand that reference into multiple line of code. That's what it does. So when assembler starts, it pre-process your original source code and create an intermediate source code expanding your macros. So this is not a function call. It actually creates and generates a new intermediate code with expanding your macros. Okay, function call is completely different concept. It basically jumps to your subroutine, execute that, and come back after executing that. Right. So this is not, again, repetitively I'm saying that this is not a function call. You please don't mix it up with a function call. It is practically your text expansion of the macro you define. Okay, it's a text expansion of macro you defined, and assembler creates an intermediate code before it goes into pass 1. All right. Now about the pseudo instruction. So pseudo instruction are instructions provided by assemblers. It looks like processor native instruction look alike, but it is not really implemented on the processor. Processor only support, let's say, 60 or 70 different instructions, which are the basic instructions. Pseudo instructions are not part of that that set of instruction that processor provides. But this set of this pseudo instruction can be implemented with 2 or 3 basic instructions. Okay, couple of native instructions. So assembler automatically replace this pseudo instruction in the combination of native instructions. So for example, BLT, it's called a branch on less than as a statement. So what it does basically, it in this example, let's say $8, $9, and L1. So it takes a set that if my registered $8 content of it is less than content of register 9, then go to level 1. Okay, that's all. But this is a pseudo instruction. PLT is nowhere in the list of MIPS instruction set. So what it does, in fact, you can use it in the code. It looks like a native instruction, but assembler will replace that with 2 instructions, which is called SLT. This is a basic instruction, and BNE. This is another basic instruction for MIPS. So SLT means you set the register 1 with the comparison value between register 8 and register 9. So if register 8 is less than register 9, set it to 1, otherwise set it to 0. Then BNE, okay, branch are not equal. $1, $0 is always having a value 0. We'll later see that in successive lectures, but assume that $0 is always 0. So it's saying that if R register 1 is not equals $0 or it doesn't have a value 0, go to L1. Otherwise, you just follow through the sequence of instruction. So point is that BLT, for example, looks exactly like a native instruction, but it is not implemented, not supported by the processor, and assembler will go and replace this instruction with 2 instruction. For in this example, 2 instruction. It can do more instruction for more complex pseudo instruction, but it will replace for this example with 2 different native instructions that is supported by the processor, but implements the same concept whatever is been given with through the BLT. That's the pseudo instruction concept. And also, as I said, you can loosely think of the pseudo instruction as macros provided by predefined by any assembler, but that is very loosely said, right? This is not really goes through the macro expansion and stuff like that. It has some other mechanism through which it basically expands your source code into your couple of basic instructions.